What if you could build a robot without writing a single line of code? This is what we're going to test today. I prepared all these parts so we can assemble a simple robot with a Raspberry Pi as a brain, a camera as an eye, some motors so it can move around, and some batteries so it's not connected to the wall. First step will be to build the robot, then install some AI stuff on the Raspberry Pi, connect Telegram and talk to this robot via Telegram. And the best part is that I have no idea if that will work. Also, I've never worked with Raspberry Pi, I only worked with Arduino. So grab yourself a drink and let's see what happens. We start by attaching all the components to this platform, which will be the structure for the robot. It has some pre-drilled holes. This 3D printed part will hold the motor. This 3D printed piece will be holding a metal rod. Later you'll understand why we need it. This is the third one. We attach these rods here. And just like that, we have the wheel holders and the rods attached. Then I will be using this to power the thing. This is a module where I can put 3 of these 12 volts batteries. This is a quite practical solution if you're a DIY enthusiast, by the way. Nice, and the last one will be the camera. Just like that, the camera is attached. The next one is the servo. And lastly, we connect these two together. And then all the camera assembly will go here. With this we can see that this will be the front and this will be the back. Now I've attached these terminals so everything will be connected to here. Then we will have 12 and 5 volts for the Raspberry Pi. This bad boy will convert the 12 to 5 volts. I also soldered some wires to these controllers. And now let's attach them to the structure. Just like that, we have the module attached to the terminals. And also I've added a switch so we can turn the thing on and off if it tries to conquer the world. I'm going to use 3 batteries here because like that I can swap them and the robot can continue running while I'm swapping them. Now let's attach the motors. In the back I have a special place for the nut. That's why I don't have to hold it from the back. And finally we can attach the rims. Cool, now it starts to look like an RC car, but if we look below, we can see that the clearance is not very great. So if I flip the wheels like that, the clearance should become much better. Now I've added this black 3D printed piece on the top and this is the clearance we got. Looks much higher and this is much better. The next step will be attaching the wires to the motors and then to these controllers. I had to detach these wires since they are too short, and now we will solder a new ones, which are basically the wires from the Ethernet cable. And just like that, we have all 4 motors connected to the 2 controllers. We have more and more cables on the robot. Basically 2 cables are going from the 12 plus volts, other 2 cables are going from the 12 minus, then 2 minus cable goes up, and plus 5 volt also goes up. Now if we attach a nut to the rods, once done we can install a second platform. There we go, this is the second layer, and now we can attach 4 nuts to hold it well. Before I thought that the Raspberry will go on this platform so the cable can reach, but looks like the Raspberry can go down, and this platform will be left for other stuff, because maybe I will add a robotic hand in the future. So we can leave these rods disconnected now, and let's connect everything to the Raspberry. The boring part is over, everything is soldered and connected, and now we can pop in the battery and see if it burns or if it turns on. We keep in mind that this is a fresh Raspberry Pi, no code is installed there, but if I pop in one battery and turn it on, at least we should see some lights, or some smoke. In a 3, 2, 1... Nice, and we can see a green light on the Raspberry, which means that it's starting up, and then we have the red lights on the controllers. That also means that they are working fine. I think we should also see a light on the camera, but most probably we will see it when the camera will be on. Now let me bring the screen and the keyboard so we can work with the Raspberry. Basically speaking, the most interesting part is starting now. Now, if I turn it on when the screen is connected, we should see some image on the screen, because the Raspberry Pi OS is already installed. Good. Let's connect it to the Wi-Fi, of course. Now, if you remember the thumbnail, we will use OpenClaw, which will live inside the Raspberry Pi, and using AI it will make decisions. Now I need to update the OpenClaw because I installed it before to test if it works on Raspberry Pi, and it does. Let's also install 2 more modules. And as we can see, the Raspberry Pi is still working fine. Now let me do all the wiggling and waggling with OpenClaw, so we can talk to it via Telegram. And once done, we continue. Now we got a reply that Telegram sender is approved, and if I type start, this is what I get. And this replies comes directly from this robot, which is pretty insane to me, but what we'll do now, we will set up the camera and we should see an image on the screen. I will not install anything myself, I will just send a message and see what happens on the screen. This is the first message I sent, and this is the reply I got. You can pause the video to see the reply. With the next message, we will set up the camera, and if everything works fine, on the screen we should see a window pop up and a camera feed showing up. I send the message now and let's see what happens. Let's take out the camera cover. Damn! Well, this is upside down, so I will not program anything, I will just ask flip the image 180 degrees. In the next message we say good boy, and then we ask it to flip the camera so it's not upside down. And if everything works, we will see this image flip right now. Yep, that worked. It would be great to add a microphone and a speaker so we can hear what it does, but for now we can just read the telegram to understand what it's doing. So basically the robot is seeing myself. So this is the screen, this is the camera, and as you can see, the camera is attached to a servo. We can see the LiDAR sensor on the iPhone is doing something. What? Anyways, I don't want to burn my camera. I hope you understand what's going on now, because basically I'm just filming the screen. But the next step will be so the robot can use the servo to move the camera up and down. If everything works fine, you will see the camera move up and down. Indeed, we saw the camera move, which is pretty crazy because it looks like the robot is becoming alive, and we got this huge reply. Now let's try to do a full sweep, from 0 degrees to 180. Now I send it and we see what happens. Basically, our robot is becoming alive with more and more messages I send. This looks like magic, and this is the reply we got on Telegram. Now, if you noticed, the server is pretty shaky, so let's fix that with another message. I just send the message and let's see if the camera will move smoothly. And the most important part is that I'm not doing anything with my hands now. By the way, this was the message, and if you want to read the reply, you can pause the video and read the reply. Now we see that the camera is staring up, so let's make it stare to the front. I send it right now, and what should happen is that the camera should move down and save this position, because this is basically looking at the front. That took about 10 seconds, and this is the reply we got. I mean, that's pretty crazy, because if you think about it, if somehow AI gets into a normal humanoid or a normal robot, and then somehow it will start prompting itself, basically that robot can become alive. And now, of course, we are not done yet, because the Raspberry Pi is connected with USB Type-C, and we have the battery to use, and also it can move, if it will use these modules to move itself. So, as always, let me clean everything, place the robot on top, and then we continue playing around. Great, and after 10 minutes, this is our workspace, and this is our robot, and now let's make it move. I will be honest, I was a bit lazy, so the robot doesn't know how much charge is left in the batteries, but of course that will be fixed in the next videos. So we turn the robot on with this magic switch. I think I should also add an LED, which will light up only when the OpenClaw is active. Like that we will know that the robot is doing something. Let's ask something like that and see what it does. This is what we got. To add the ability to move, I will send this huge text. Also, let's move the robot like that so it will not fall. This is what it said right now. Basically, of course, it will need more sensors to identify that it moved 10 centimeters forward. So we just saw the robot move, and this is the reply we got. Basically, I need to answer these questions so the robot knows how the test performed. And what we saw is that these wheels were moving forward, this wheel was moving backwards, and I have no idea what this wheel was doing. This is the reply I'm going to send. Just send it and let's see if it will move forward now. And again, it drifted to the right. Again, no idea what this wheel is doing, but I think we have to invert this one so that it will move forward. This is the prompt I'm going to send now. And let's see how it will move right now. And now I'm sending this prompt. Looks like it can move forward, but the speed control doesn't work. Let's see if it can fix it now. And now we are sending this prompt. I will also give it more space so it can move freely. From what we saw before, I think it became worse, because we only saw one wheel spin. So I will send this prompt now, and let's see if it's able to do it now. Now I did some hardware changes to the robot, basically removed these jumpers, and let's send this prompt to see what will happen. Yep, and indeed that worked. Here I mark with the arrow where the jumpers were, so if the speed control doesn't work, we have to remove the jumpers and it will work. And lastly, we send this prompt so the robot can turn. Let's see how many degrees it will turn now. I think that was around 25 degrees, so that's what we sent. And let's see if now it will turn 90 degrees. Damn. Now this is more or less 124 degrees, so that's what we say. We put it parallel to the table and send the prompt. Yep, and now this is more or less 90 degrees. Let's do a last tweak by telling it that it was 95 degrees instead of 90. Then we put it parallel to the table, send the prompt, and let's see what happens. Looks like I didn't say that we should test it now. We simply say that we're testing the right turn now, and it should turn 90 degrees to the right now. A bit weird that it didn't use the same timing as for the left turn, but anyways, I will tell it now and let's calibrate it off camera. Great, now all the movement scripts are ready. I did not write a single line of code, but everything worked. So now I will be sending this prompt so the robot can use the camera as its eyes. If everything works fine, it should say that it sees a person. So right now I'm standing in front of the camera, and looks like we got a reply from the bot. We got this huge reply. If you want, you can pause the video and see it. I will send this now and let's see if it will solve everything. For some reason it asks for the approval. I will just approve the command, and I guess this is done so that AI does not conquer the world. Everything should be approved by humans. At least for now. Well, this is what we got, and looks like I have to use my Mac to connect via SSH, and then I simply run this command. Alright, that took some 20 minutes, but that's what I did, and let's see if our robot is able to work with that. I simply send the prompt and it should reply that it sees a person. Yep, looks like we're starting to have some technical difficulties. Let's see if this prompt will solve everything. Let's see if it can perform the steps it suggests. And looks like the problem is the Python version. I have 3.13 installed and we need to use 3.11. So I just installed 3.11 and let's see if it can continue now. Let's make a question mark in the end. Looks like we need to approve this command and everything should start working. You may find a multimeter on the table because I was checking if the battery is running low, and actually it was running low, so I had to swap them, and the hot swap worked. Which is very good because in the future this robot can be swapping the batteries itself. And again it asks for approval, so of course I approve and let's see what happened. Great, looks like we got a reply that I was waiting for. So if it will tell that it sees a person now, it's working 100%. Damn! And look at this. Also here it is what the robot sees. More or less. And this brings us to the final challenge. The final challenge will be that I will place the robot somewhere there, myself I will hide somewhere here, and the idea is that so the robot uses all the created scripts, it can go forward and backward, it can turn, it can swivel the camera, so it uses all that to find myself in the garage. So the robot will go here, maybe even looking to that direction. The prompt I'm going to use is this prompt. So I myself will hide here, and let's see if the robot is able to drive these 2 meters and then find me here. The message sent, let's see what it does. Well, we got this reply, that basically the logic to search for the person is not implemented yet, but we can implement it and see what happens. I will reply just that, and of course the idea is that we see that it moves the camera and also turns right and left. In theory, if it turns and finds myself, it will already be pretty astonishing. I will now text it so it can turn 90 degrees instead of like 20 that it does now. Alright, maybe I can bring it a bit closer, here, and I will simply sit down here. This is what I'm going to send, and let's see what it does. And this is what we get. Nice, I find you. And also the step it suggests is pretty good. Let's do that and see if it will actually stare at me. The prompt is sent and let's see what it will do. Everything is looking good. Well, we got all this reply. If you want to read it, you can pause. I guess I would have to tweak this off camera, but I have no more time, so I have to end the video now. It is pretty crazy what we can achieve with Raspberry Pi, OpenClaw and AI models. Keep in mind that all the components I used are pretty cheap ones. Of course, if I use expensive ones, it will work much better. Also, we can add a graphics card to a Raspberry Pi, so it uses some local models for something. But for me, it's pretty crazy because I felt like a dad who was teaching his kid basically how to walk, how to see, and what to do in the life. I will continue tweaking this one in the future, and in some weeks I guess I will post an update, so you can subscribe not to miss that. Also, if you want to play around with that at your home, everything I used is linked down below. Of course, they are affiliate links, but if you want to buy it, you can buy it from there. Anyways, I feel pretty surprised because this guy is kinda alive. So excited where this project will go in the next months. And of course, everything will be shared with you guys, so I will see you in the next one.